Yes. Yeah, so there's no, like a slope, it's always growing by the same, right? It's a straight line. But what you're going to see with exponential things is they start to grow super fast. In fact, you're going to go off the graph after too many points. Okay, so what we do is sometimes you look at like my grid here for this one. Do you see how the y-axis has a lot, goes really, really high because it grows really, really, really fast over time. Okay. So remember how I said if it was a line, if I had points, if I added in between each or subtracted them and they had a common difference, we did that last semester. What do you think it would look like if a list was exponential? What do you think, Eden?
Would keep going higher faster or lower faster?
Yeah, so we're going to call that, if instead of I added in between each term, if I divided each term and they had the same ratio, then it's exponential. So how can we tell if a data is exponential? The ratio between each set of points is the same. The ratio between each set of points is the same. Okay, and we'll get to some of those a little, like when we look at some in a minute. Ooh, have you seen this before? What is an asymptote? Never seen that word before? Okay, an asymptote is a line the graph approaches. It never touches it though. So I'm going to draw an XY axis. Here's what I want you to draw on your XY axis. Would you have a curve, and would you make sure the curve starts just above the Y axis, but it doesn't touch it, and then it goes up like this? So this part of the graph is going to get lower and lower and lower and lower and lower, but it's never, ever, ever going to touch the x-axis, okay? Here's what I mean by that. Okay, you guys have your calculator ready? Okay. You're writing it down. I'll give you a second. Okay. Would you start with the number 10? I'm going to show you something exponential. My multiplier is going to be a half, okay? What's a half of 10? What's half of 5? I'm multiplying over and over by half. What's half of 2.5? What's half of 1.25? 1.125. What's half of that? Okay, so did I do that right? Okay, do you see what I'm saying with this? If I take half of this, is this ever going to get to 0? No, it might get to like 0.0000 something eventually, but it's never going to get to 0. That's what that means. Okay? It never gets negative. So it gets closer and closer and closer. And the only way we can draw that is like an arrow. I can't go way down here to infinity. That kind of sometimes blows some people's minds. Like, if it's going down, how come it never goes to 0? So it will also never go below the x-axis. All right, let's do an example. Mrs. McDonald's AP Stat students currently study for an average of 6 hours per week. So right now we have the 6 right there. After spring break, they will be reviewing to take the AP Statistics test. They will have 5 weeks to study and plan to double the amount that they study every week until the exam. Okay, let's do it. So I start with 6. After or during week 1, how much are they studying? 12. And then now, week 2, 24. Okay, and it's in the week, Shane, but you're onto something, I think. Okay, their plan might have a flaw in it. All right, what about the 3rd week? 48. Cheryl, I need you to put that away. Like all the way away, not on your lap, down on the floor. I can't see it again. Double 48. And then,
192.
okay.
It's more than 190.
Okay, so what we're going to get to, Shane, we're going to do some calculations, and we're going to see, is this maybe a good plan, or are they not really thinking about what's going to happen after 5 weeks, if it's feasible. So here's how we plot it. Let's keep in mind we're going to plot the points. Do not draw a line. We're going to, when it's done, draw a nice smooth curve. So 0, 6, my scale is going up by 20, so I'm going to put 0, 6 pretty close to the x-axis. 112, well, halfway to 20 is 10, so I'm going to put the 12 slightly above halfway. 224, okay, so 20, 40, halfway would be between 30, so put it closer to the 20. It's not going to be perfect, so there's 224. Hey, at first it doesn't look like it's curving, does it?
No.
348 would be about there, close to 50. 496 would be a little below 100. 192 would be slightly above 200. So hopefully you can see there's no way you can make one line go through that. Then we draw a curve through those points. Okay. So, remember back to here. We're going to write an equation. What we're going to start with is the initial value. Who can identify for me what's the initial value in this scenario? Jordan? Yep. So my equation is going to be f of x equals, and I'm going to write 6. I write what I start with. What I write next is the multiplier. So times, what was I multiplying by? 2. And the x goes up here, so that tells me how many times I multiply by. When I multiplied once, I got a 12. When I multiplied twice, I got a 24. So we're repeating that multiplication over and over. Okay, so you're telling me, Shane, what is the likelihood that this is going to happen? Well, how many hours are there in a day? 24.
It's over a week.
So 24 times 7 days, there's only 168 hours in a week. So is this even possible? No. But this is how many they're studying just in that 1 week. Yeah. So not possible. Week 5 exceeds the hours in a week. And I would even say in a week. In week 4, that leaves no time for even like sleeping, so.
That's fine. Don't mess around with it.
That's what she would do? Just stay up.
No, like make her kids do that. Not her kids, but you know.
Her students? Oh. No, the students do that on their own. You can't make somebody go home and study, but they care about it, then they will. But yeah, it's not possible.
Watch it.
All right, let's practice writing equations again. So remember, we need our initial value and our multiplier. And if you're thinking it's divided, change that to multiplication. So first, let's find the initial value. It's on the y-axis, where it's 0. So the initial value is your a, that's right there. So what's my initial value? 5. So I'm going to write f of x, or you can write y equals 5 times, can anybody tell what I'm multiplying by? Let's see. 5, and it went down here and here. Yeah, it looks like a half. And you might say, well, how can you tell that for certain? Let's go back a point. Before the 5 was a 10. Didn't I multiply by 1/2 to get from 10 to a 5? So my multiplier is, you can write it as 0.5 if you want, or you can write it as 1/2.
When did you start?
It's where the graph hits the y-axis.
Oh.
Okay? So that's why I highlighted right there. So this would be my exponential function. It's decaying, it's going down. All right, what's this one doing? Somebody tell me the initial value of this one. I even wrote it right there. 4. And then I tell you after 1, it goes up to 8.
2.
What do you multiply 4 by to get to 8? 2. So the multiplier, and that is 2. So I would write f of x, or y, equals 4 times 2 to the x power. Make sure you put the x in the exponent so I know that it's repeated multiplication. All right. Is this good? Okay. Which one of these looks harder to you? Second one?
Yeah. Yeah.
Okay, so let me show you how you do this one. I need you to get a calculator out for me, okay? First of all, I don't even have to put the 0 in. This goes back to what happens when you put a 0 into an exponent. This part is 1. And if I multiplied 21,004 by 1, I'd get 21. Yeah, so that's why we don't even bother with, we just say, hey, that's the initial value. That's why. So let's put that on the graph. I know this is a weird scale. Just do the best. Here's 20,000 and 22,000. 21,000, I'm going to put it about halfway in between, okay? All right. So, if you want to write that value down, you can. All right, so we're going to just multiply by 0.86. Let's do this for a couple times. So, I have 21,004 times 0.86, and I get, can you see that? I got 18,063-ish. Just leave it right in your calculator. So at 1, I'm gonna go slightly above 18,000 there. It isn't. We just got to remember to multiply instead of. All right, 2. Just do it again. So here's what you could do. I'm going to show you your choices. You can leave it in your calculator and multiply by 0.86 again. Or, if you want, you can go back and type it in like this. 21,004 times 0.86 to the second. They're going to give you the same exact answers. Because that's what I'm doing. I'm multiplying it twice. And this does that for you. 15,534. Here's 14,016. I'm going to put it a little above halfway between the 14,000 and 16,000. All right, let's do it again. So times 0.86 again. 13,359. Are you guys getting this?
Yeah.
Do I have to keep writing them in the table, or can you just keep doing that? I'm going to do one more. You want me to keep writing them?
Yeah. More visual.
Just, we'll call it 60. Uh, 11,489, and then one more. Okay. Now, I know what it looks like. Oh, I could maybe draw a line, but you got to be smarter than that. Make it a curve. It's curving down. By the way, what do we call this? Growth or decay? Decay. And if it would continue, it would just go, if you follow my pen, it would go down, 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 but would never cross the x-axis. And draw an arrow there. All right. Gosh, there's lots of examples here. Let's just do some. So you guys all have your calculators, right? Because you need it for this. So remember how I was saying to check if something's exponential or not? We're going to check the ratios. Ratios means we divide them, okay? Let's do table 1. So to check the ratio, I start at the back. And I'm going to do 32 divided by 16. Oh, I know that. What's 32 divided by 16? 2. I'm working backwards because if I divide, that reverses the multiplication. All right, let's go back. How about 16 divided by 8? Is that also 2?
Yeah.
Yes. Okay. How about 8 divided by 4? Is that also 2?
Yeah.
Okay, let's do the rest in our head. How about 4 divided by 2? Yes. 2 divided by 1? Yes.
Yeah. Yeah.
1 divided by... Okay, so is this data exponential? It is exponential. The ratios are all 2. Can you guys pick out one to me that looks like it's not? Tell me which one you think it's not. You think this one's not? Oh, I see why. You have a 0 in the middle. Can you do that? Let's check. I'm gonna check though. Watch what happens. I'm gonna leave it on my screen. If I have 19.8 divided by 8.8, I get 2.25. If this is exponential, when I keep going, they should all be 2.25. Or really, really close. When it's real data, then sometimes it's a little off, but not a lot. All right, so what should I do next? 8.8 divided by 2.2. Whoa, what's that ratio? 4. Very, very different, right? Multiply. I know 2 and 4 might not seem like a whole lot different, but if I multiplied something by 2 rather than 4 over and over again, that would be a big difference. Okay, so this one is a no. Or not exponential. Let's abbreviate exponential, EXP.
They don't match.
Yeah, ratios are not equal. What about this one? Let's just check it out on our calculator. I get a 0.2 when I go backwards. I'm going to do that. I'm going to just write it like this, 0.2. So times 0.2. 0.12 divided by 0.6. Ooh, that's also 0.2. Are they all the same? I'm going to just write exponential here. This would be enough work if you showed me that you got all those same ratios. Both. So, I'm gonna, this is how multiplication works, okay? Okay, can you see what the pattern is? What am I multiplying by? 3. But if I went backwards to figure out what that ratio is, I would do 27 divided by 9 because I'm trying to figure out what it is, if that makes sense to you. Because sometimes you can clearly see, oh, I'm multiplying by 3. But if I'm not sure, you can always take that and divide it by the previous one. That's why I said start at the end. How about the money in Olivia's bank account? Is that exponential? Yeah, what's the multiplier? What's being multiplied? Yeah, she only started with 1 cent. Oh, I'd love this though. If you tell your parents, you can give me a 1 cent allowance but triple it every week, you're gonna be rich children. At week 6 you wanna see why? You don't believe me, Santos?
No.
You don't believe me, do you? Okay. All right. Watch. This is week 6. So after a month and a half, you're making $7.29, and your parents are tripling it every week. Whoa! All of a sudden now, in week 7, you made $21.87.
Yeah, less than 2 months.
Oh, okay, Santos. You can't wait 2 months. Watch what happened. Watch what happens now. This is 8 weeks. 9 weeks. 10 weeks. Are you looking at the calculator? Are you looking on the screen? How much did you make in week 10, Santos?
Well, You can make that in like 2 weeks if you want the job.
Right, that's 1 week. I'm saying in week 10, your parents paid you for week 10. That's how much they paid you. What's going to happen in week 11?
It's gonna get bigger.
Oh, really? You're going to make a job that is $1,771 in a week?
Yeah.
Oh, really?
Yeah.
Now, and you're only into month 3 now. Now you're making $5,000 a week. I would take that deal, unless you're Santos. Maybe they don't know. If you tell them 1 cent, they're like, oh, sure. And they don't think about it. Maybe they don't know exponential growth like you do, Shane.
Alright, 40 goals.
Okay, so this one's a yes. The ratios are all 3.
We literally have $1 million.
Okay, Shane, check this one out for me. Can you? Is this average weight of by age of Atlantic Ocean rockfish? It's actual data. Start dividing. Yes or no?
It's a rockfish.
No, that does not make any sense.
Yeah, it's not.
How can?
3 and 4 are only 35.
They're like weird numbers.
I know they're weird numbers, but I'm going to show you something. At first, I think I got 1.28, 1.26. This is real data. That's close enough. Let's see, 117 divided by 68. Oh, that's where it goes haywire. Then it's 1.7. Yeah, so you're right. I would say this is a no. So you have to be same throughout the whole set of data. Okay, let's pick some problems for you. We won't do all of 10 and 11. In fact, let's just, let's do page 10. Okay, so you're going to just compare and contrast. Compare and contrast means tell how they're the same, how they're different. No. It's not a test. It's just a little quiz. That's how long it is. It's a little opener quiz. Just a little opener quiz. Compare and contrast means find how they're the same, find how they're different. See if you can find some things. Okay, like this one, they're both exponential. This one's, these are a lot different. Anyways, at least find one same and one difference for each. Okay? You're making your equations, and then I'm going to have one that you graph on your own. You take your pick, Shane. Which one do you want to graph on your own?
No, hold on.
Okay. Did you make sure you started that?
Just no.
Don't X everything else out because we're going to use it eventually. You're doing page 10, and then you're doing that one graph on your own.
That one's massive.
Definitely what?